Hello, Dan here from howtomechatronics.com. In this tutorial, we will learn how to build an Arduino-based RC hovercraft. I will show you the entire process of building it, starting from designing and 3D printing the hovercraft parts, including the propellers, to connecting the electronics components and programming the Arduino. For controlling the hovercraft, I used my DIY Arduino-based RC transmitter, which I made in one of my previous videos. I set the right joystick to control the servo motor for positioning the rudders on the back side of the thrust motor, set one of the potentiometers to control the lift propeller, which is actually attached on a brushless DC motor, and set the left joystick to control the propulsion. So let's take a look what it takes to build this RC hovercraft. This video is sponsored by JLC PCB. JLC PCB is a manufacturer of high quality PCBs, which are used in many industries for prototyping as well as DIY projects. Once you have your PCB design ready, simply upload the Gerber file, review your PCB in the Gerber viewer, select the properties that you want, and order your PCB at a reasonable price. If it's your first order from JLC PCB, you can get up to 10 PCBs for only $2. To begin with, I designed the hovercraft using a 3D modeling software. You can find and download this 3D model, as well as the STL files which are used for 3D printing on the website article. The link to it is in the description of this video. So, the basic working principle of a hovercraft is that the craft is lifted by a cushion of air. The central propeller blows air into underneath the craft, which inflates a skirt made out of soft material. When the air pressure in the skirt is high enough, the craft gets lifted. The constantly supplied air escapes from the middle of the craft, between the skirt and the ground, which creates additional lift and also reduces the friction between the hovercraft and the ground. Once lifted, using the second propeller, a thrust is generated, which moves the hovercraft forward. On the back side of the thrust propellers, there is a simple set of rudders, which are utilized for steering the hovercraft. Nevertheless, once I finished the design, I started with 3D printing the parts. The hull of the hovercraft is the biggest part to print, and I specifically designed it to fit my Creality CR10 3D printer, which has a printing bed of 30 by 30 centimeters. There is also a link to this 3D printer in the description of the video in case you want to check it out. So after the printing is done, it's time to do some cleanup. The main body of the hovercraft, or the cockpit, was the longest print, which took around 18 hours to print. Because of the curved design and because I wanted to be a single print, there was a lot of support material used for this print. However, it was really easy to remove it and the final piece turned out just perfect. The hull of the hovercraft was printed upside down and it had just a minor amount of support material to be removed. Actually, I had to make some adjustments to this print and cut some material out of the central blower housing so that the skirt holder can fit in properly. I will update the 3D model before attaching it to the website, so you won't have this problem. Some of the round areas of the parts were a bit rough, so I used a simple sanding paper to smooth them out. The propellers didn't need any cleanup and they worked quite well coming straight out of the 3D printer. Okay, the next step is painting the 3D printed parts. I didn't use any primer before, but directly applied an acrylic paint in a form of a spray paint. I used the chocolate brown color for the first coat. For some of the smaller parts, which are actually just decorating parts, I used a lighter brown color. In order to make the hovercraft look a bit cooler, once the first coat dried out, I continued with adding 2 more colors to the parts. For that purpose, I made some random patterns on a simple sheet of paper and used them to make stripes and spots in different colors. I used lighter brown and black color for that purpose. I really like how the parts turned out, so once they dried out, I continued with assembling them. I started with installing the servo motor, which controls the rotors, onto the thrust blower housing. I secured the servo using two M2 bolts and nuts. Next is the brushless motor. The particular model that I have is the D2830, which has a diameter of 28mm and 30mm of length. And of course, the housing is specifically designed to fit this motor. Here, when inserting the motor, first I had to pass the wires through the openings. It's a bit tight, but still manageable to pass them through. Then on the back side, using 4 M3 bolts, I secured the motor to the housing. Next, I can merge the truss housing with the main body of the hovercraft. This part has an opening so that the servo and the BLDC motor's wires can pass through. However, once I placed it, I noticed that the servo bolts were raising up the housing, so I made a small holes using a drill, and then I was able to place the housing flush to the main body of the craft. Then, using 4 M3 bolts, I secured them firmly together. Once I finished that, I continued with installing the second brushless motor to the hull of the hovercraft. Here again I used the same method. First I passed the wires through the openings, and then on the back side I secured the motor using the 4 M3 bolts. Okay, next comes the electronics. The electronic components will be placed in between the hull and the main body of the hovercraft. But before we do that, let's take a look at the circuit diagram and see how everything needs to be connected. So, the brain of this hovercraft is an Arduino board. With the Arduino, we can easily control the servo, as well as the two brushless motors using the two electronic speed controllers or ESCs. For powering the BLDC motors, I will use 3S LiPo battery, which provides around 11 volts. And for powering the Arduino, we can use the regulated 5 volts, which the ESCs provide through their battery eliminator circuit feature. For the wireless communication, I will use the nRF24 LO1 transceiver module, which if used with an amplified antenna, it can have a stable range of up to 700 meters in open space. The RC transmitter that I will use for controlling the hovercraft is the one that I custom built in one of my previous tutorials, so you can check it out in case you need more details about it. There are also detailed tutorials on the nRF24 LO1 module and how to use brushless motors using Arduino. Nevertheless, the basic working principle is that the transmitter sends the joysticks or the potentiometer's data to the receiver, which controls the speed of the brushless motors and the position of the servo. There is one more small detail on this circuit diagram, and that's the battery monitor. I added a simple voltage divider made out of two resistors, which is directly connected to the battery, and its output goes to the analog input of the Arduino. The voltage divider drops the 11 volts to around 4 volts, which are then acceptable by the 5 volts Arduino pins. With this, we can monitor the battery voltage and set an LED to light up when, for example, the voltage of the battery will drop under 11 volts. So I started connecting the components as explained. For connecting the two ESCs to a single battery, I used a parallel battery connector splitter type XT60. Note that there are links to all of the components used in this project in the website article, in case you want to check them out. For adding a power switch to the project, I used another XT60 connector on which I cut one wire and soldered a toggle switch there. So one side goes to the Y-splitter cable and the other side goes to the battery. Next, I placed the ESCs into the main body and trapped them between it and the hull of the hovercraft. Then, using 4 M3 bolts, I fastened the two parts together. From the top opening of the body, I then inserted the battery into the cockpit area. Next, we need to connect the components to the Arduino, and for that purpose I added 2 pin headers to the Arduino, which will serve as ground and 5V pins. Here you can see how I connected the voltage divider to the battery, as well as the indicator LED, which I inserted through a small cylindrical 3D printed part. So once I connected everything to the Arduino, I passed the NRF24L01 antenna, the indicator LED and the power switch through the top cover of the cockpit. Then I just needed to squeeze everything into the cockpit. It was a bit tight here because I used Arduino Uno and I probably should have used an Arduino Nano instead. However, I managed to fit everything in, also attached a small decorating part to the cover, and then I just clipped it to the cockpit body. I continued with installing the steering system. First, I connected a small link to the servo horn using M2 bolt and nut. Then I inserted the first rudder in place and secured it to the truss housing using a 2mm metal wire, which passed through its body, and so the rudder can rotate around it. In the same way, I attached the second rudder. This rudder has an additional slot, so we can connect it to the previously inserted link to the servo. Again, I used M2 bolt and nut for securing them. Finally, I connected the 2 rudders to each other using another link, and with that the steering system was completed. Next, I will attach this small decorating part on the side of the hovercraft. Using a drill, I made a small hole and then secured the part to the hull using a single screw. I placed these parts on both sides and I think they fit quite good to the overall appearance of the hovercraft. Okay, next I continued with making the skirt for this hovercraft. You can notice here that the skirt holder has holes around it, and that's for attaching it to the hull. There are also slots for nuts to be placed in, and in that way we will be able to easily secure the skirt holder to the hull using M3 bolts. Once I secured all of the nuts in place, I continued with making the skirt, for which I used a simple trash can plastic bag. So first I applied an AC glue to the middle area of the holder, and then glued it to the plastic bag. Then I offset the perimeter of the holder at around 6 cm. I marked it at several points and then connected them together. Using a utility knife, I cut the plastic bag to the proper size. Then I flipped the skirt and added some additional holder to the bag where I previously glued it using the AC glue. Next, the outer of the bag needs to be glued to the top of the holder. Again, I used AC glue for that purpose and carefully secured the plastic bag to it. Once done with that, here's how the skirt should look like. Next, I made holes through the plastic bag where the bolts should pass through. The skirt holder is just 1mm smaller than the hull of the hovercraft, so in combination with the plastic bag, it fits into the hull perfectly. For securing the skirt to the hull, I simply fastened all of the M3 bolts around the whole perimeter. There is one more thing to be done to the skirt, and that's cutting out the central area of the plastic bag. So with this, half of the air will directly inflate the skirt, and then it will bleed out through this opening, creating an additional air bubble in the middle. Finally, what's left to be done is to attach the propellers to the brushless motors. For that purpose, I am using the collet that comes with the brushless motor. It's really simple and effective way of fastening the propeller to the motor shaft. However, I lost the collet for my other motor, so I had to print a different version of the propeller to directly fit onto the motor shaft, which is 3.15mm. The print actually came out pretty good. It fitted and secured perfectly to the motor shaft without even using a glue. And that's it. With this, our radio-controlled hovercraft is finally done. However, what's left in this video is to take a look at the Arduino code and how the program works. So first, we need to include the RF24 library for the radio communication, as well as the servo library for controlling both the servo and the brushless motors. Then we need to define the radio and the servo objects, some variables needed for the program below, as well as the structure of variables which are used for storing the incoming data from my DIY RC transmitter. For more details how this communication works, I would suggest to check my particular tutorial for it. In the setup section, we need to initialize the radio communication as well as define the pins to which the servo and the ESCs are connected. In the loop section, we read the incoming data from the transmitter and we use that values for controlling the servo and the brushless motors. So the joystick incoming data, which varies from 0 to 255, is converted into a value from 0 to 50, and we use these values to control the position of the servo. With the same method, we control the brushless motors using the ESCs. The incoming data, which is from 0 to 255, is converted into values from 1000 to 2000, and using the write microseconds function, we send this data to the ESC as a control signal. For monitoring the battery voltage, we read the analog input coming from the voltage divider, and with some simple math, we convert the input values into real value of the battery voltage. If the battery voltage drops below 11 volts, we simply light up the indicator LED. And that's it. In case you need more details, you can check out the other suggested tutorials, and so you will be able to fully understand how everything works. I hope you enjoyed this video and learned something new. Don't forget to subscribe, and for more tutorials and projects, visit howtomechatronics.com.